A gazillion years ago, well, about 2005, myself and a couple of others were looking at what you now know as your wireless access point or your hotspots. Now, this was done in response to slow internet speeds from providers, where the internal networks and wireless could always be faster than what was being provided through then ADSL, which had just started out, and ADSL2, as well as ISDNs, and even still dial-up connections. So what we did is we got together on a hardwireanalyst.com where loads of us techs used to hang out some 15-17 years ago, and we developed quite a lot of the infrastructures that you see today. So what we did then is what we're going to do now in this short video. This is part one of the Gwisp network which was set up. So some credit has to go out to Sam Sanderson, who did Chili Spot and the software behind this, because what we did have is quite a simple network system back then, where we would have a wireless access point which people could connect to, but what we needed to do was to make it more secure and monetize it as well, so people just couldn't just connect up willy-nilly. So the other side of this is the WRT. They did the software programming for the routers. Assassin did the development with the kiosk side of things, and I middle managed what we needed to do to make it all work together. You know, the securities and things like that. So what we've done today, or what we did back then, was create most of the access points and software derived from those access points, which probably most of you have used at some point as your free wireless or Wi-Fi connection when you're out and about or at a pub or something along those lines. So what I'm going to do now is probably something that a lot of people have tried to do globally, which is to set up their own ISP or their WISP, wireless ISP, in their local areas as a community network. Now, a lot of people have tried this and failed, or have a very small network. The point is, I've looked online at a lot of the videos of these companies and community projects trying to do this, and I've seen some of the issues that they have with their backhaul system, last mile, point to points, and load balancing. So in this set of videos, we're going to be looking at the backhaul system and how to load balance. Now, this load balancing system was a software that I had, which could monitor each of the nodes and load balance, which has to be obviously ran from a server. Now, a lot of these businesses or companies or community groups are not actually thinking wider scope and backhaul. It's because it's not a normal type of an affair where you would deal with internet access as a layperson, as probably the fundamentals in the development of the network. So without further ado of me rambling on, let's have a look at what we need. So one of the fundamentals to any network is obviously the access. So what we have is our remote users on our wireless or Wi-Fi adapter, which we'll push to one side, and then we have a radius server that allows the request so they can remote in. On there is a database where we have our users that connect into the or authenticate into our network. So that will be your user accounts, your amount of usage you get, or your speeds, and various things are all controlled via the radius server. So to deal with that, you need to set it all up correctly. Setting up a Radius server is relatively simple and straightforward. Install the server with the SQLs to create the database with its known key tables that you'll need. So you'll have your username, your password, your nodes, your data usage, speed limiting, and all of this information needs to be ran through via the routing nodes. So what happens is that's one end there, and so you have a load balancing server. Now the load balancing server is the actual key to having a ultra high speed network. Now to do that you need to have your network set up correctly, and that includes backhauls. So let's have a quick look at backhauls. So I've just quickly googled a image into what are backhauls just to try and get some explanation to you. Now as you can see on this image here, which is dark for you, let's go over to this one here and zoom in for you. As you can see, your network or your primary hub goes out wirelessly to these nodes, and from those nodes it comes back to the network. Now this backhaul could go that way, which is the fastest route or fastest packet. That will be set up by your server, which will load balance and compress data, because you could literally jump from one point to another, but the backhaul effectively can give you your ultra high speed network as well as point to point through the nodes. So load balancing for the groups of people in those areas is really quite important. So one of the key areas of load balancing is obviously how you route your network. So this requires a network monitoring, where you will pick out your network, each node which serves other people, and your backhauls, because you don't know whether your node is the fastest route or a backhaul. So here's a quick rubbish picture. So if your nodes are all wireless, and we'll say these are your remote ones and that's your main one, the connection between each of those, so there we go, to your user here is really important, but which one is the best? Now if we're load monitoring, if this one has 100 users and this has 10 and this one is central, what we would probably do is we would want this node here to go, well look, I'm busy, can you use this other node which you're connected to, or this node? And so this is load balancing across your network. So as you can see, what you'd do is, if this one's too busy, this might be transferring data this way to this connection, or it might use it a backhaul connection if the wireless becomes over a certain threshold. So then you'd want this one connecting, and this might have low level connections, but obviously if both of these are connecting, this one, the load is going to be greater, so you would want to go down the backhaul. So I hope that makes perfect sense of how you would load balance. Now this gives you both backhaul and a normal standard network load. So the redundancy has to be built in just to balance the load, because there's no point in having two nodes you know, and more users across one whilst you have another one not really doing anything. So it's essential that the backhaul system and load balancing system works. So you have to be able to get data from each of the nodes to see how many people are connected to it, whether it's using a wireless connection via the node or the backhaul connection, which is the lowest load. So that's a relatively simple equation to do and to set up into your load balancer. So that's quite an easy way. I hope that makes perfect sense to you, is to not overload any of the nodes, and so the nodes go, look, I'm busy, use this one. That has to come down, that needs to go onto your server, and that should have you up and running. Rather simple, really. So when looking at TwoSpot, we have our firewall router, our internet, we'll call that a node, we'll call that a different node, and we have people accessing the network via the router. Now this is load balancing out, and we can split off and offer different services across the network. But the important thing is our software here, and as you can see, the DDWRT control panel is rather simple and straightforward to set up. I won't be going into that in this, but there are videos online. Just type in ChiliSpot and you'll get a, let's have a look at this. So here's our wireless side, our captive portal, which gives us our website and our radius server. So as you can see, there's not a great deal here. What's missing from here will be the load balance server and compression servers to make all of this side, your WAN, web server and internet access, all work more effectively. So as you can see in that really small example, the internet speed here on this setup is just a simple wireless connection into an access controller, which is then checked against a radius server, and that when people connect up to the access controller, they have a captive portal or a website where people can log in, create accounts and pay for the services that they want. This obviously links over to your radius server, and then we go out to the internet. So what we can do is we can dump various things on that server and create various access to certain services that we want to provide. Web servers, VoIP, media, files and that kind of thing that we want in our own network. Say I'm an ISP and I offer people websites, emails and video access to certain libraries, exactly the same way as what the internet works, but in a private closed network. What we would want to do then is our internet access, which we can control via the radius server, just to allow people to connect to the internet should they wish to, and how much access they get. So you want speed and you want data amount. So you don't want everyone at full speed with unlimited data, because it does clog up your network. Although most people who have access to internet will just use it as and when, it's not a full-on system. But then you may wish to put in security and lock down ports to stop certain you know, constant torrent downloads and that kind of thing, where it will use a lot of your network services and obviously cost more. Processing time costs money and power. So that what we don't want to do is to have someone doing bulk 100, 200 meg downloads a second, you know, just for the sake of it, when you have a compression server. And this is where I put in going compression and load balancing server, because the compression server and load balancing server really does make a big difference. Load balance will put the data to different paths or routing packets, packet routing it's called. That's one side of it. Then you want to compress the data so that you can pump more data through your network, which means that you have to have more processing power to compress that data down. Certain things compress better than others. Then you want a cache server. Now the cache server will cache or hold certain files which are regularly used by your network. So for example, the Google logo, and things that would normally come up. This would be cached on your caching server. Your Facebook, your email, the little graphics that don't really change that much will all be cached, so you're not downloading it across your internet. Now this obviously, the caching server, then your internet connection or requirements are lower, therefore you can produce more speed, because the details and information is cached locally to just pump across your network rather than the internet to your network, then to your users. And also each user can actually share the one file download rather than having, say, 250 customers downloading it 250 times. It just makes sense to cache it. So you just make a caching server. It's really simple. And that is the compression and the cache. So I'm writing it down, so I got a little picture to follow. The compression and the cache always go together. The load balancing will go to the radius server, and obviously then down to your node controller. Node controller will be the network monitoring. So that's really nice and simple. So what you need to do then is to get hold of all the software, and I have to actually turn on some of my servers which have all the software on them. It's not installed on them, it's just that when I developed the network back in 2006, I did keep a copy of all the software that I was developing, writing, and we edited up. So it's got the pre-edits and the raw files of what we did back in 2005 to 2007 when we developed it. So what I'll do is update, because I know that I have to change one of the servers over now. It's become obsolete, the software for that. So yeah, so what we're going to do is literally push together all the software pack, put it into a little package, set it all up, program it, and then we're going to roll out a simple network, because I still have all the stuff back from 2007 when we stopped. Well, I stopped for a big reason, and so I've kept all the hardware that we used to use and bought for that project. And so it should be relatively simple and straightforward, you would think. Unfortunately, because I have, obviously, it's what, 12-15 years ago, the details of how to set it up are not exactly fluid knowledge to myself, but we had Gwisp, and I have its folder still. This included a data network and a phone network, because they could run on the same thing, and that's not VoIP, that's SIP in fact. So yeah, so SIPs are different than VoIPs, same as your VoIP type Skype calls that most of you use. It's a lower grade system, but we go for the higher grade SIP system. So we do have you know, telecoms iTech, which I developed in 2010. And before that, which was the integrated telephone exchange convergencies, so that the mobile phone network could work across it, and it was slightly different than that. It was more robust. You know, you could make a phone call to somebody. If you knew their email address, it would just connect over to them so they could accept the calls, and it would be a virtualized private network or communication hub. So yeah, so what we'll do is we'll be including the mobile part of this, but we won't actually be activating it, because it's a whole complete IPv4 setup on top of the network, which integrates into the network. But what we'll do is we'll set up the network so that it does integrate already. So what we're going to do is we're just going to focus on a data network, and we want our speeds to be around about between something like 80 and 100 megabits per second both ways on that. So that gives ample connectivity to clients, and also our bandwidth load that we can push across our network. we'll be doing backhaul and things like that anyway, when we see how this project captures the imagination of users, or clients, shall we say. If it's there and it makes money, then it makes money. If it doesn't, it doesn't, and then that can just all be switched off. It's just not here to make a big loss. So this is probably GWISP, and probably some sort of basic introduction to GWISP and how the telecom and data network works together, and how to actually set them up. So what do you need? Okay, so what you will need will come in a second. Setting up a WISP or wireless internet is relatively simple-ish. Now, the main factor is point-to-point and location that you can broadcast your network across. But fundamentally, before you even go into that side of it, which is a precursor to actually making the network, it will be the hardware that you need. Now, the average older server you can pick up for relatively cheap amounts of money these days, so you can actually put on a fairly modern, at least quad cores. You can dump on there probably 3 to 4 server apps onto the one server, and so therefore you can dump your data or your server requirements onto one server without it slowing down too much. Now, RAM is going to be one of your big issues, and the speed, also the network connectivity, because the server will effectively pull in your internet from one side and control the speed on the other side. So this network port is going to be critical to your overall speed. So you want at least gigabit LAN. That will give you ample speed, but you'll need more of them. I have under this desk a number of servers. In fact, there's one here against the wall this side, and I have another 3 dotted around. Now, the optimal way of doing this is to separate your account side. So get a completely separate server from anything else and just have your account side there, and you want a backup system. So you want a SAN, not a NAS, a SAN. Now, a SAN is essential because you want multiple servers with a load that replicates the data and also keeps it as a backup, so you've got redundancy built in. There's no point in building a network where one computer could fail. A bit of hardware in there would take down the whole network, otherwise you'll end up like Virgin did. So what you need to do is to have a router, and it needs to be a gig plus. Now, I'd recommend getting something like a 10 gig network and a fibre network. Now, this doesn't have to be your fibre internet connection, but within your own network. You have to be able to connect your servers together, and your public server has to have high speed connections. You can't give 100 megs to 10 people if you have a 100 meg connection. It doesn't work that way. Or you cannot give 100 meg to 10 people. You can give 100 meg to 10 people if you have a gigabit connection. So can you see where the problem is there? By load balancing and nodes and backhauling, this really does change the playing field of how it actually works. As long as your node is controlled well and your packet routing is controlled well, then you are only sending small bits of data essentially from your own network. So you don't have to have a massive, great big speed network. However, the minimum you want to do is probably a 1 gig connection, because you have to send out data and you may actually have to reserve bandwidth specifically for network traffic, packets, nodes and data within the actual network itself, rather than just raw data speeds. So what we'll do then is we're going to make a rather simple network, and we'll want to have our radius server and accounts all in one place we want our load balancing and monitoring in another place, we want our compression server and web servers all on the same hardware, and so that you get the best speed out of that. And then you need your router and your router solutions. So a fiber channel and Ethernet channel is probably going to be your targeted hardware. You can pick these up for not a great deal of money, and if you're starting out, used is perfectly fine, although you don't know the history of it, and that can present problems at any point during your build. So you must make sure that you have the hardware that you need, that you have redundant hardware, because if you buy something that's very rare, old and hard to get hold of, you won't be able to find a replacement part just to switch over and get going up and going in a relatively short period. We're going to be using the WRT software on some routers and access points to allow us to connect, although technically I could literally just have it open and use any source and then have it all controlled by the server rather than having any control at the access point. And this is really what you need to do. You just need to have a limit and a authentication, and that's really it, and that really does go down to your server. So you need to have multiple connections for that, and so a single port on an old computer isn't really going to cut it. You need to have more robust solutions, and I'd recommend probably going and getting yourself an old business server with 8 or 16 cores on there, and get ready to set it up with probably 40 to 60 gigs of RAM and very fast RAIDed drives on there, because you need to have the speed, because everything that you have that will be slow will effectively give you network lag and longer ping times as you get a queue. So the noding is important, and basically you just want it to route correctly, and we'll go through that stage as we come to it. So I hope you've liked the introduction to this series, how to set up your own internet service provider wirelessly, or your WISP, and now you have the basic understandings of your hardware and your software that you need to start this type of project. We have our own antennas. I developed them back in 2007. There are legal requirements of what your broadcast power can be. I'd recommend to people the following. It is easier to hear better than it is to shout. So if you have your your RX connection should have a high gain antenna. There's no legal limits or requirements there. You can have quite a big antenna that can hear more. This allows a better connection, although the hearing at the other end needs to also be good, but your broadcast and your point-to-point will deal with that in a separate video. Just remember that if you have a connection with 4 decibel and 4 decibel limits, yeah, that's great, but if you have a TX, which is your RX, which is your receive at 8 decibels, you can hear the 4 decibels a lot further away. So just make sure that you take that into consideration of how you build the fundamentals to your network here. So I hope that this has been insightful to you, somewhat educational. Do subscribe, make sure you click on the playlist to subscribe to rather than the channel, because I don't just do this, I do other things too. Thank you for watching, and I hope to see you soon. Please put any questions or comments in the box, and hopefully I'll answer them all. Goodbye.